Welcome back to my channel. Today I'm going to do a comparative analysis of compression spring wherein I'm going to choose different cross section for the spring. So let's start. I'm going to first click on static structural. I will rename it as circular cross section. I'll go to engineering data sources, general materials. I'll choose the material as stainless steel. I'll go to project, update project. Now I'll go to geometry, right click, new design modeler geometry. I'll go to units, millimeter, XY, look at. I'll go to sketching. I'll first draw a line, dimension 70. I'll create a new sketch. I'll go to sketch 2. I'll draw a circle. I'll give it some dimension. I'll go to sweep option. Profile is a circle and path is the line. Apply. I'll give turns, say 15. Generate. So this is my regular compression spring. I'll double click on model. I'll go to geometry. I'll select the solid. Structural steel. I'll change to stainless steel. Mesh. I'll change the sizing to fine. Update. Now I'll go to analysis settings. Okay, I've not sliced the spring, so I'll just go back to my geometry. I'll select this face. New plane. I'll offset in Y, say by 30 mm. Generate. I'll click on slice. I'll choose this plane 4. Generate. You can see the conical spring has got sliced. I'll go to model, double click on it. It'll ask if I want to read the upstream data, which means whatever I have changed, do I want to incorporate in my model? I'll say yes. Now each solid has to be changed to stainless steel. So I'll change each of them. So I've changed all the solid to stainless steel. Now I'll just update the mesh again. Now I'll go to analysis settings. I'll choose the lower face. And another one. Right click, insert, fix support. I'll choose the upper two faces. Right click, insert, force. I'll change vector to component. In the downward direction, I'll apply a force of minus 500 Newton. I'll go to solution, solve. I'll go to solution, right click, insert, stress, shear stress. Right click, insert, deformation, directional. I'll choose y-axis, solution, solve. I can see the shear stress here. I'll go to deformation. Now I have received a message over here, so what I can do is I can just change the force to minus 200. You can see there's still some error, so I'll change the force to minus 100. Solve. This is how you can just debug the errors and find out the value which will best suit the component. Now you can see the error has disappeared. So this is how I debug the errors. Now this is the shear stress value which is obtained. Also, if I go to directional deformation, this is the value. I can click on max min and get the values. Similarly for shear stress. So this is one analysis which I have done for a regular compression spring whose cross section is circle. Now I'll just change the cross section of this compression spring and we will see the results again. For the next analysis, I'll go to static structure and double click and I'll follow the same procedure till I go to geometry. I'll rename it as rectangular cross section, engineering data, stainless steel, update project. So I'm just going to geometry, new design modular geometry, units millimeter, XY, look at. I'll draw a line. Dimension is 70. I'll make a new sketch. I'll go to sketch 2 and now I'll sketch a rectangle. I'll give it dimensions. I'll give the value as 4 by 3 or I'll give it as 4 by 4. That's better. So I'll just make it into a square section. It'll be easier for me to solve. And I'll give the distance. If this is totally 4 and from the center I want this distance as 12. So from this point to this point, from this point to this point, the value will be 14. Now I'll go to sweep. The square is the profile and the line is the path. I'll choose the number of turns as 15 and generate. So this is how the compression spring will look like. Okay, I need to make the slices as well. So I'll select this rectangle, new plane, offset Y at 30 mm, generate. I'll slice the model, apply, generate. So I'll just double click on the model. I will apply the material as stainless steel to each of them. So I've allocated stainless steel to each of them. Now I'll go to mesh, sizing, coarse to fine, update. I'll go to analysis settings and I'll choose the faces on which I want to apply fixed. So I'll insert fixed over here. Next, I'll come to this face. Right click, insert force. I'll apply the same value of force here, minus 100. Solution, solve. I'll go to solution, right click, insert, stress, shear, right click, insert, deformation, directional. I'll choose Y as a direction and solve. So you can see again it's showing it's large. So I'll go to force minus 50, solve. So you can see the message is not there anymore. So I'll just go to shear stress. So this is the value. I'll go to the first one which I've solved. The shear stress I got was 120 over here with 15 turn, and directional deformation was 0.005. Here the directional deformation is 0.00058. So this is the deformation that I get. Now what I'll do is I'll just go to this model, and in sweep, instead of 15, I'll just make it to 12 and generate. You can see the spacing has increased. So I'll go to geometry, right click, update geometry from surface. I'll mesh again. I'll go to fixed and I'll select the faces again. Apply, solution, solve. I go to shear stress now and the directional deformation. I'll just change the force to minus 100 and solve again. So you can see still the force is going to be large enough. Actually in rectangular one, the spacing has become less. The pitch is less between these turns that you see. So this value has become too large for it, or the area also could be less. So that's why there's a problem. So what I'll do is I will just leave it to 50. And solve. So I get these values. Next I'll go to static structural again. This time I'll take hexagon as a shape. So I rename it as hexagonal cross section. Engineering data, I'll choose stainless steel. Project, update, I'll open geometry. Units, millimeter. XY, look at. Sketching, I'll draw a line. Dimension is 70 again. I'll make a new sketch. I go to sketch 2. I'll choose polygon option. I'll give it some dimension. Say 4. And I'll give the distance between this point and this point as 12. I go to sweep, select the profile and the path. Number of twists, I'll change it to turns and I'll give it 15 again. Generate. You can see as the geometry changes, the spring is going to have very less pitch over here, so its load bearing capacity will reduce, and also it will not be able to absorb the shock so much. So if you see over here, in fact there is an interference also between the surfaces, which means I cannot choose 15, so I will have to choose say 12. I can still see interference, so I'll make it to 8. Now I get some spacing or some pitch as we call it. In fact, if needed, I can just change this value of H to 3. So it has a more pitch now. So I have taken the value of side for the hexagon as 3 mm, and I have taken the number of turns as 8. I can change it to 10 now. So this is fair enough. Now I'll need to first slice this. I'll select this face, new plane. I'll change the transform to offset Y. The distance I'll choose as 30. Generate. I'll make a slicing using this plane. Generate. Now I'll go to model and double click on it. I'll go to geometry and change each solid material to stainless steel first. So I've changed all the materials to stainless steel. Now I'll go to mesh. I'll change the sizing to fine. Update. Then I'll go to analysis settings. I'll choose these faces which I want to apply fixed. Right click, insert, fix support. On the top face I will select, right click, insert, force. I'll change vector to component. In the Y direction I'll apply -100 initially. Let's check. So this is working fine at -100. I'll go to solution, right click, insert, stress, shear, right click, insert, deformation, directional. I'll change the direction to Y, solve. So this is the value of shear stress, 75 megapascal, and this is my directional deformation, 0.001031. So here I have taken 10 turns and I have changed the dimension of the side to 3. So everywhere you can see that I have chosen different values of dimension, and I have also given different turns. For the first one I could give 15 turns, for the second one I had to choose 12 turns, and for the third option I have chosen only 10 turns. So as the geometry becomes different, the number of turns will either increase or decrease based on the area that it is going to occupy. The two pitches, the two turns should not just merge into each other, otherwise the flexibility of the spring will be lost, because there should be some gap between both the turns so that the spring is able to compress and is able to absorb the shock. So this is a comparative analysis that I have done with 3 cross sections. You can assume any more cross section by increasing the side of your polygon, or you can also choose a rectangle instead of a square like I chose at the end. You could just go with a rectangle and solve. I hope you have understood this numerical, and this is how simple problems can be solved. This was a doubt question which I have solved of a student. If you have similar doubts, do let me know in the comment section. I will solve your questions and I'll upload the video for your understanding. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. Keep supporting the channel so that I can bring more analysis for you. I'll see you in the next session with another numerical. Thank you.